My name is Leigh Hollins. I'm a retired battalion chief from Cedar Hammock Fire Rescue in Manatee County, Florida. And today we'll be filming some training minute videos, and the topic will be response to gasoline tanker emergencies. What I'd like to show you in this particular segment is the application of foam onto a tanker that may be on its wheels, as you see behind me. It may be overturned, it may be in many different positions, and the situation is going to be either you have a spill or a fire of petroleum product. So these tankers, they carry various commodities, but the most common is going to be gasoline or diesel fuel. So with that situation, if you arrive and you have a spill that's covering a fairly large area, which is going to be common, especially with an overturned tanker trailer, then what you want to do is you want to try to determine how much foam you need to apply as far as how much foam concentrate. So as a very simple formula you can use is to figure out how many square feet you need to cover with foam and then divide that by 20. So for instance, if you have a 100-foot circle, if you did the math, that's going to be about 8,000 square feet of area that you need to cover with foam. Whether that is a spill that you need to suppress the foam vapors with a blanket of foam, or if it's on fire. So either way, you're going to need 8,000 square feet divided by 20. That is quite a significant amount. So what we're going to do is we're going to look at this situation, and we're going to go ahead and look at the various components of applying that foam to this tanker trailer. The first component in the system to properly apply foam to a tanker trailer will be your water supply. So that's going to start at your fire hydrant. You want an adequate hydrant that is going to supply the gallons per minute that you may be flowing. So keep in mind, although we're just going to show one line flowing here in an actual incident, you may have multiple lines, or you may be supplying a foam trailer with a master stream line. So you got to have enough water supply. So we're connected to a hydrant here of sufficient gallons per minute. We have a pumper of sufficient pumping capacity to supply our system that we may be using to cover this area with foam. So the pumper is going to be, in this case, pumping an 1.5-inch line to a foam eductor, an inline foam eductor. Some of those eductors accept a 2.5-inch intake line, and others an 1.5-inch line, such as this situation. With that said, we want to pump 200 psi at the eductor. So that's what you need, 200 psi at the eductor for the system to work properly. So the only other variable is going to be the friction loss in the hose from your pumper to your eductor, which could be 100 feet, it could be 500 feet, and depending on how many gallons per minute you're actually flowing will determine your friction loss. So we'll go ahead and look at the next component in the system. The next component in the system will be the inline eductor. So this particular eductor, 1.5 in, 1.5 out as far as the threads. This is a 95 gallon per minute eductor, and what you have here is you have an adjustment on here on how much foam this will pick up into the system with your pickup tube, as you see here. So it's important that we have that set correctly. For instance, if you are applying foam to normal petroleum products, the basic rule of thumb on that is to supply 3% concentrate into your hose line. So that's set at 3%. However, there's also other situations where you may be dealing with petroleum products that are polar solvent, which would be E85 gasoline, ethanol, alcohol, these type of things, and you would need to double your foam concentrate to 6%, because a polar solvent means it is a product that mixes with water. So it's going to break down your foam. So what we're dealing with in this scenario, diesel, gasoline, we're going to set this at 3%. And this particular setup here takes 200 psi to here. And then the other rule of thumb is you cannot have more than 150 feet of hose from your inline eductor to your nozzle. So keep it 150 or shorter to that nozzle. And this will supply adequate foam that will take care of covering a leak, spill, and or a fire situation. You have to have enough foam to keep this going. With that said, a lot of departments don't have a lot of foam, but you would apply whatever you can to control the situation. So that's what we need to know about the ductor system. Simple, and we'll move on to the next component. The last component in the system will be the application of foam with the nozzle. So in this situation, we have a fog nozzle that matches up with the ductor as far as 95 gallon per minute nozzle, 95 gallon per minute eductor, and you can apply foam to your scene with simply a fog nozzle, but it won't be nearly as effective as if you have the other component, which is an aerator, which attaches to this nozzle in order to aerate the foam and water liquid as it comes out of this nozzle will make a big difference. So Brett will go ahead and just show you how this attaches. It's a simple attachment method. And something also to mention is we have a backup line in place, which is also a critical component. You always want to have a backup line in case something goes wrong with your initial line. And again, you see how simple it is, but this will really add to the foam application by aerating that foam, creating a lot more bubbles. That would be covering our spill or extinguishing a fire and using the foam that is in that concentrate bucket, and then we'll have to swap out those buckets as we need to apply more foam. With this particular application of foam, since we don't have a wall to bounce off, we're going to try to rain this foam down on this tanker, and in this situation we're going to simulate that there's a fire at the rear of the tanker, and you can see the application of the foam and how it's going to cover the product, whether this is just a spill or whether this is a fire situation. That's the idea, is to try to rain this down on that tanker, as you see here. In this session, we looked at the application of foam onto a tanker trailer that was involved in some type of a spill, leak, or fire situation. We reviewed the various components of the system and what it takes to apply foam to these particular scenes. And one of the most important issues is how much foam concentrate you will need to apply depending on how large the scene is as far as how much of an area you need to cover with foam. So we talked about the formula earlier, and you need to take a look at that and make sure you have enough foam for any particular incident that you may respond to. I'm Leigh Hollins. Thank you for watching Fire Engineering's Training Minutes.